So hello friends, I am Neeraj. In this session we'll be talking about pointers. So what pointers and what is a variable and what is a pointer? So what is the difference between variable and a pointer? So actually the difference lies in terms of the variable is holding its value, and pointer you can think of it like that is a special kind of variable that is actually storing the address in the memory. So in order to basically moving on, so first let us try to create a variable just like this, and we will also print it out. So print ln, and we will say value of x, and it is equal to, we will pass on the x here. And if we try to run our program, go run main dot go, so we are getting the value of x as 10. So we have initialized that with the integer 10. That's right. So but before understanding pointers, so let us also understand how data is stored into our actual memory. So let me draw something similar here. So let's say, try to visualize it, this is a memory, and each block is having its own specific address. So for example, say when we wrote something like x is equal to 10, so let's say the value 10 comes here and x is placed here. Okay. So actually, this is going to be to have some specific address, so that we will see very shortly, and this is basically in the terms of hexadecimal and few numbers. So like this, so this one is also having a specific address like 0x and dot 1, and it was 0, something similar. So when we wrote something like x is equal to 10, so what with this statement, what we mean is we are assigning value 10 into variable x, and actually x is stored here at this address. So compiler knows actually where we need to find the x variable into actual memory. So actually, and actually like referring to with the proper addresses, this is literally very difficult for us to remember and what the address is, and actually this is dynamic, so we cannot do that way. So this is how actually the data is stored into our RAM, and our compiler knows it. And now let us try to see if we try to if we need to see the actual address, so that also we can do it, and very simply we can write it something similar. So let's say address of x, and all we have to do is just place an ampersand before x, and if we run it, our program, the same program, so the value of x is 10 and the actual address of x is this one. So this is a hexadecimal number, and basically this is referring, this address is this address where x is stored into our memory, right? So this is it. Let me clear it out. And so right now, like we know whenever we whenever we declare or initialize a variable, and what will happen inside our memory. So this is how we got the address of the memory. And let us try to do some other stuff. So let's say we declared a variable y, and we assign this variable as an pointer to x. So now see, let us see what happens. So we will just simply duplicate this stuff, and here we will say value of y and address of y, and we will also replace x to y. That's right. Now try to run our program in the same very way. So value of x is 10, address of x is this one, and value of y that is holding is this one, and address of y is also a different address. So let me draw it here, something similar. So with this one, actually what is happening here, for example, again say this is our memory. So this is x, the value came in as 10, and this in this memory block y is actually having 0x and dot 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 this address. And actually what is happening here is that this the value y is holding, that is holding actually the address of x, right? And the value and when we wrote something similar, x is equal to 10, so actually x is pointing to this one, this address, and y is, and when we wrote something, when we wrote this statement, so actually what we are saying is that assign the address of x into the value, into the variable y. And what is the address of x is? So address of x is basically that is pointing to this one, right? So this is why this is why as per the output, so the value of x is 10, the address of x is this address, and the value of y, actually y is holding the address of x, so that is why these two are similar. And again, since y is also stored into a different memory address, so that is also having its own address. So let me try to clear a few stuffs, and also let us see something also very important. Okay, now if we write something, and we can also go this way, we can also access the value of actual y holding. So value of y, let's say y pointer, and in order to access the actual value, we have to write it something asterisk and the variable and the pointer variable name. So let us try to run our program again. So this time when we are running our program, so we are getting value of x is 10, address of x is this, value of y is this, so this is what the value it is holding, and address of y is this, and this is very important, value of y pointer, that is actually holding the value of 10. Why so? With this statement actually, so see this ampersand y is called as the address operator, and this is called with the asterisk y. We are telling that we need to get the value of the address where y is pointing to. So when this statement got executed, so with this one what we are saying is that give me the value of the address where y is pointing to. So it came in here, and once it got the address, so it pulled the value of the x, and that is why the value of x and the value of asterisk y is same. Okay, and now we can moving on further. So we can also, if we try to, we can right now with, since we have got the actual access to the actual address in the memory, so we can modify the value of x also using y. So how we can do that? So very simple. So just asterisk y is equal to, let's say we are going to assign it to 5, and now if we try to run the same one, so let's say value of, or maybe let's say go with the printf, because we need to actually format it specifically. So value of x, that is equal to %v, and we will say value of asterisk y. Asterisk y is basically that is a pointer, so we will say ampersand, we will say only plain x, and we will say ampersand y. And now if we try to run our program, so we are getting the value of x is 5, and the value of extra int 5y. So okay, value, I forgot to provide an, yes, then now it's fine. Now if we try to run our programs, also let me put a new line character, so /n, just for the sake of clarity. So here we are getting the value of x is 5. Initially the value of x was 10, and actually we didn't change, we didn't touch the, we didn't reinitialize the value of x, but we have we have wrote at the line number 19 as the asterisk y, and right now the value of x is 5, or x also got changed, and the value of y is also got changed. So so actually try to understand what actually happened here. Again let me draw the same memory block. So let us see, this is x holding value 10, this is y, this is having the, let's say, address of x, something similar. So when we wrote this, try to focus on the, try to understand on the what is happening inside on line number 19. So here we are saying that we want that the value of y, where it is pointed, where it is pointing to, that should be 5. So what is happening here, when this line got, when this statement gets compiled and executed, so we are saying that y, that 5 should come at the address where actually y is referring to. So y is having the actual y is holding the address of x. So right now this is saying that we want to have the value 5 at the address where y is pointing to. So y is pointing to the address of this, the address in the this memory block. So this is why when this statement got executed, so actually we were able to change the actual value holding at the address of x location, because we are already having the address of x. So that is why using y, so we can also access the actual values inside that address. So this was actually, pointer is very nice concept, but yes, again, so one needs to be careful using pointers, because using pointers, so we can have access the actual memory address, and maybe there can be situation that we can I mean accidentally we can since we are having the address, the actual address in the memory, so accidentally our program can it may happen that sometimes some malfunction happened, and accidentally we reinitialized or we modified the value inside the other addresses. So also we can do each and every mathematical computations, and not only this, rather let me clear it out here, and we can also have another variable. So let's say z equals, and that is an address of y. So remember, so ampersand is the address operator, and so right now so this should be clear enough. So till now, that here we are saying that the variable z is the value of z variable, that should be the address of y. And if we try to again write it something similar, so value of z, and we'll say %v, and we'll also pass z. And if we try to run our program, so we are having the x is 5, y is asterisk y is also 5, and z is actually pointing to the memory location of y. So likewise, since likewise we can also access the value, the actual value. So if we go that way, one asterisk z, and if we try to run our program, so we will get the value of actually the memory location of y. And if we need to access the actual data, what is being referred to by y, so we can go with the double asterisk. And if we now if we try to run our program, so we are getting the x is 5, asterisk y is 5, and this, let us try to make it asterisk z. So we are having all the 5s, and if we change at any given location, let's say if we go with the asterisk z equal to, let's say, 100. So we will change, we are actually going to change each and every, actually we are actually changing the value of this variable. So but let us see what happens. So we are getting x is also 100, asterisk y is also 100, and asterisk z is also 100. So we could be able to modify the actual value of x. However, there was no direct relationship between z and y. Rather, z was referring to the location of the to the address location of the y, and y in turn was referring to the address location of x. So that is why that is how pointers are very much powerful, and basically it is the pointers are very helpful if we try to create a complex data structure like linked list or double linked list. So without pointers or without actual memory access to actual access to actual memory location, so that is very difficult. So that's all for this session, and I will see you in some other session. So I hope you enjoyed the session, and if you have any doubt, any query, so please do let me know in the comment section, and I will try to answer them as soon as possible. So till then, take care and happy coding.